All right. Everybody awake? Survived the weekend? Easter Bunny was good to you? You did not get chocolate for Easter? Oh. The chocolate eggs? Yeah. Yeah. There's candy all over our house right now, which is just horrible. So, your assignment, if you paid attention to the email and the announcement, I moved it up actually due tonight at 10 p.m. just to give you guys as much time as possible. Which I always suspect what that really does is make everybody procrastinate just a little bit further over the weekend. Make sure you get that turned in. This one actually should be fairly simple compared to some of the other ones. We're actually going to do a little backwards migration, and we're going to go back to chapter 7 today and finish up a little piece. We didn't get as far as I'd like to. This semester's had flooding and snow days and all kinds of fun stuff, so we're a little behind where I'd like to be. I did start on the final for this particular class, and so as we had kind of talked about, there's a couple of different options, so I am going to throw out both options. So hopefully by tonight, if I can find time, I've got kind of a crazy schedule today, bouncing around like a ping pong ball. Excuses. I will have your option of the programming final if you want to take that up. And I'm trying to make them kind of equitable in time in terms of time, effort, and everything else. So there will be the option of taking either a programming final where you create a program or a objective test final. So there will be two different options in here. So the test will probably be 50 questions, combination of multiple choice, essay, short answer, true, false, matching, whatever other kinds of questions we can put in there in that particular thing. Just as a reminder, we will not have that final on campus. So you do not have to show up on Thursday at 8 a.m. However, I will have these set up so that at midnight on Thursday they will expire. So I'll send out lots of emails. I know you guys are getting tons of all kinds of emails and everything else about classes and finals and all kinds of things. So if you will join me and go back to page, some of these pages are different. If you'll find the beginning of chapter 7, we're going to look at how to read and write to a file. Everything we've done so far works really neat. We have some really neat things to be able to add to lists. We can create games. But right now, we don't have any way to actually save a file. So in other words, nothing I do is permanent. Well, I want to correct that. And so I want to look at chapter 7, where we talk about how do I actually read and write to specific files. So in my book, it actually shows up as 188. But I know that there's several different versions of this book floating around with some different pagination. So the first thing we're going to do is we're going to look at reading a file and some of the structure on how we can use Python to read and write to a file. So the first thing I want to look at is we need to talk about this type of files that Python can read and write to. And so the most common thing we do is we actually use just a text file. And a text file is kind of handy. We can get to it with almost any computer program, any computer out there. And in fact, I'm going to grab out of the material that you can download. There's actually a couple of text files in here. And so this one called Read It Text, if I open it, it's going to open and it says line 1, this is line 2, that makes this line 3. Nothing very particularly sophisticated, but we need to look at how Python can interact with something like this. And so we need to figure out how do we open and close a file and how do we access that particular file. The one thing I will say that makes this more challenging for some students is we're so used to storing things kind of out in this nebulous cloud without knowing exactly where they're at. And much like in web programming or anything else, we need to make a reference to this file. And so for the most part, we're going to reference this file as being in the same place as our Python file. If we change that location, we have to also change how we point to that particular file. So we're going to look at this from the standpoint of we're going to put everything in one single file. So we're going to see if we can address this particular file and read and write to this particular file. So I'm going to make a new file somewhere. I think I even have one created. So once again, we're going to look at reading a text file. So we're going to figure out how to do this. And so we need to find a variable. And so the first one we're just going to use is we're just going to create a variable called text file. And we're going to say that's equal to open. And inside of here, notice there's a lot of information that pops up. We're going to put the name of the file, and notice it's got to be in quotes. And then we're going to put in another character we're going to pass into this function. So this is really a function here called open, and we're passing in data. And so we're passing in data with a couple of different comments in there. And in your book, let's see if I can find the page that it's on page 193, on open and closing a file, there is file access modes listed. So table 7.1. So we can read a file, write to a file, append a file. In other words, we write to the end of the existing file. You have R+, so we can read and write. W+, write and read. But notice how some of those read. So if we don't have a file, it writes a new one. So picking the right mode can be very important. In this case, we're just going to try to read it, so I'm going to put an R in here. So we have this idea of we're going to read a file, and we're going to read the file named readit.txt. Okay. And we're going to do it with R mode. The other thing we're going to do, and it's kind of a very important piece, anytime we open a file, we need to close a file. So the same thing. Now, there's a couple of different ways. The dot notation is probably the easiest way to close a file. So we open a file, we close a file. Anytime we interact with a file, we want to make sure that we both open it and close it. Because Python, for all of its great wisdom, sometimes gets a little confused about files. And if you leave some open, it can actually cause some issues with what you're trying to do later. So all this does, bless you. So all that does, open and closes a file. Nothing actually really exciting has occurred. You just said, hey, I want to open it. I'd like to close it then. So if we want to go one step beyond, we want to actually read something out of that. So this is reading something from file. So this one character at a time. And we want to look at something a little weird here in just a second. So I'm going to open this file up again. Well, I'm not going to retype this because that looks pretty ugly. I'm going to actually grab both, if I get the cursor in the right spot. And I'm going to do plunk Because I know that that opened and closed it, so now I'm going to put something in the middle. So I'm going to just do a print statement, and I am going to print text underscore file. So in other words, this is what we opened. And I'm going to read a particular value. So 12 maybe. And I can read one character. Well, maybe I want to see it with a couple of more times, and I want to go chunk, chunk. And so maybe I want to read character 6, whatever I happen to do. And so we can actually run this and try to see what's going to happen. So I'm going to hit F5, and it's going to force me to save it. I want to make sure that it's in the right folder where my text file is. And so I'm going to pull this down just temporarily and say all files. Yep, my read it text is there. And so I'm going to save this as readfile.py. Now normally I don't have to put the .py in, but I pulled down to all files so I can make sure that text file is there. So now I want to see if this actually is going to work. And when I do that, what did I get here for an error? Text IO wrapper not callable. Did I do something really weird? Probably. Let's do it this way. Let's go back to 1 and 2. See if I get the same error. And I do. Always handy. What did I do wrong? Text file print. Text file close. Let's see what I've mistyped here really quickly. Which I am sure I did something truly bizarre and weird. Oh, I see. Never mind. I didn't actually put the... If I'd quit typing and think here. All right, so I have to put the .read in there. So now when I run this, let me move this over so you guys can see it on this screen. Move over. Oop, crap. Hang on. Vital. Bring back my file. All right. So what it did there, it says demonstrates reading from a line, one character at a time. But notice what it did here. So I said I want 5, and it did 1, 2. Whoa, wait a minute. Maybe this is working differently than we think. Because my first thought when I did that, you thought, hey, it's going to read position 5 or read position 2. But what is it actually doing? How many characters do you see printed there? Yeah. So if I do 10, let's see what happens. And it actually prints out line 1, and then it prints an S on the second line for my second print. So what it's really doing, if I look at my print, let me open this one so you can see it again. So this is what it's doing. It starts here and it counts out 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And then I do 2 more, 1, 2. So it really steps through this file from the beginning. So if I want the entire file, let's see what happens if I print Let's do 60 characters and see if it breaks it. And what it did then is it printed that entire thing. This is line 1, this is line 2. So it starts counting from the beginning, and it doesn't pay any attention to those carriage returns. And that is going to actually present us a little bit of a challenge later on. Now, we can also do some other things. So if I want to grab this entire file, obviously if I know how long it is, I could do it that way. But I can do it a couple of other ways. So I'm going to back that down just to 2. So we get 4 characters. And I'm going to grab this because that's handy. We want to see if we can open up the entire file all at once. So I'm going to do a print statement so I see what I'm doing. Entire file. All right, so we're still going to open it the same way. So in other words, we say, hey, we're going to read it. We're going to get a new variable in here. So we're going to say whole. And we're going to set that equal to text underscore file dot read. And I'm not even going to tell it what to do. I'm just going to say read the whole thing. And then I'm going to print. And so if I didn't make any horrible typing mistakes, it's going to say, hey, this opens the entire file, line 1, line 2, line 3. So we're able to access it by grabbing a set number of characters. We're able to open it by accessing the entire file. What actually is kind of interesting, though, is doing it one line at a time. And I said it ignores the character returns unless I use something a little funky here. And I'm going to do the same thing, go open, close. We can create one called read line. And quite frankly, this is almost the most common thing we do when we're working with text files, because what we would like to do so print text underscore file dot read line. And so now I'm just going to copy and paste that. I know there's 3 lines, so we'll see what happens. And I'm going to hit a 4th one just out of curiosity to see what happens. And notice it said this is line 1, this is line 2, this is line 3. Now my thought was, is it going to start back over, or does it just try to read the blank line in that text file? And it really just is trying to read that blank line, because it printed out something here, but there's no actual content, right? So the read lines makes a quick, easy way to do that. We can also do, come back up here. Oh, wrong thing I had copied. Hang on. Let me go back up and get my open and close. So copy. All right. So we can also do, by doing it one line at a time, we can put that all into a file if we would like to. So we're going to open it. I'm going to do a print just so I remind myself what I'm doing. Reading file line by line into a list. So that same data structures we've used before, those lists, can work really, really nicely for this. So if we just call this line or lines or whatever you want to call it, doesn't really matter. This name has to be the same as what you opened it as. So text file dot read lines. So now what you've done is pass that entire file into a list, essentially. So if I print lines, you'll see that. And so let me hit return. And notice it looks very much like when we printed things. And notice it even adds this weird new line character in there because that's actually in that file. We just don't normally see it. So we can do things with that then. We can address it so we could do a length. So we could print the length of lines. So we could say, all right, so we know that it's 3 lines long. That might be handy information to know. We can address individual items. So you could do a print statement. So for line in lines, print so in other words, you're passing that in. And so you could print out your lines here, line 1, line 2, line 3. You could address them individually if you really wanted to. So you could do a print statement. So that gives us a handy way to take that entire file, pass it into a variable as a list. So there's a couple of different ways we can do that, and those are really a handy thing to do. One thing I want to make sure you always do, make sure you close that file. If I don't close that file and I'm addressing it multiple times in here, a couple of things happen. When you close that file, it resets that pointer to the beginning, and so you may not know where you're actually at inside of that particular file. So page 193 has these file access modes, and that really is a great way to notice which way you're going to do it. The other piece then is we want to be able to write to a file. So we want to be able to write to our file, and maybe we're going to create our own brand new file. So I am going to File New, move that over here so you can see it. So now we're going to do one writing to a file. It works very similar. So we're going to do, just because it's a handy structure, that text file just says we're going to open it as a variable we don't necessarily need to do anything with. Now we're going to create our file. In this case, we're going to call it write underscore it.txt. So we have to explain to the program it's not very smart. It has to have that extension in there. And now instead of using the read method, we're going to use the W method. And so W is going to open it up for writing. All right, so our text file.write, and then we're just going to pass in what we'd like to do. So here we're going to say very similar things. Line 1. And notice I put that new line character in there. Well, I'm going to cheat here really quickly. And I'm going to write maybe 4 lines of text in there. And so that's line 2, line 3, line 4. And you could put any amount of text in there. What I want to do is just have some text, and I want to verify that it actually exists. So I'm going to then do my text close. So I'm going to save this really quickly, and I'm going to call this write. All right, and it didn't look like it did much. It ran, and I didn't get any confirmation of anything. So that's not particularly unusual, because all I did was send a file output. So if I go to my file folder now, and I look over here, and notice I can look at this date modified, and oh look, writeIt.txt was just modified a couple minutes ago. I open it up, and that's my line 1, 2, 3, 4. I wrote that to a file. I could put any amount of content in there. So if I want to check it in my program or actually get to it, I can do something very similar to what we did just before. I can open that file, so text underscore file dot open. Now, I'm going to move that down a line so it separates it. I have to make sure I'm at the same file name, write underscore it dot txt. And because I'm just going to read that file this time, I just went to R. And I could print the entire thing. So print text underscore file dot read. And then again, I always want to close it. So I'm just going to copy that up here. So now we read and write to a file. And so hopefully, what did I do? Something in there. Somewhere I've got a spelling error of some sort in there, I'm assuming. Text file dot read. Somewhere very silly, I've got one, I'm sure. This. And then it reads lines 1, 2, 3, and 4. So it wrote it and it read it back out. So we also have the ability to write in a couple of other methods. So instead of writing this file, so this worked, but can we make it a little better to write something very similar? So text file equals open. And this time we're going to do it slightly different. Write it .txt. And I'm going to do the W. So W for write, R for read. Get my cursor back there. All right, so now I'm going to pass in a tuple or a list item. So lines equal. And so remember I used that bracket. So the square bracket says I'm doing a list. And so I could do line 1. Remember, we could do this very easily, so we could say this is line 2. And you could put in as many of those as you want. I do, yes. So we're just separating items in our list, and we're being able to shove them into lines. So if I printed lines, it's going to print those out in our bracketed list. But we could actually put them into our file. So text underscore file dot write lines. And then we pass in that entire variable. And then I'm going to close it again. And so I'll grab my close up here. Well, I already have this here to check it, so I'm just going to grab that again and paste it down below there. So now I can see what's going to happen. I don't need this print lines other than to show you that we are creating that. So I'm going to delete that out real quick. So what happens though, and here's what's interesting, our text file at this stage had line 1, 2, and 3, and 4 in it. We wrote that. That write command overrides the entire file and rewrites it. So that may be what our intention is, but what if we wanted to add to that file instead of rewriting it? If I change this, so I'm going to go back to my table, and I'm going to say, well, what if we did an A right here and see what happens. So I think what's going to happen, we're going to write these 4 lines, then it's going to add 3 more lines on it. And so when I do my final print, it should have 7 lines. So let's see what happens if that actually is right. And so it printed the 4 lines, so it added a text file there. The next time through, it appended or added those on. So that's the difference between that W and that A. So it's a way that we can make that file do what we want, because we're actually in charge of where it's going to put it. So if I don't have that file at all, so here's my text file, I'm going to delete it. It's gone. It is no longer in that folder. But when I run this program, oh, there it appeared again, because it just wrote that file just like we told it to write. So line 1, 2, 3, 4, and then it's got the other lines in there. So we're able to read and write pretty easily that way. So on my book, on page 199, is a list of file object methods. So we have the close. We know that's this here, dot close. We have a dot read, and that read says how many characters do I want to read. And if I don't put in anything, it grabs the entire file. And for the stuff we're going to do, that's probably okay. But if I make a giant file, I may not want that. We have read line. So how many characters from a current line? And then read lines. Reads all of the lines in a file and returns them as elements in a list. So we may want to read line. We may want to read lines. So notice there's a subtle difference. And then the write and the write lines. So if I want to store data, I can do that in this already. I could say, all right, I'm going to write a file and it's going to have a high score. So maybe I want to have a high score where the text file has Mark and then his score of 199. Mary with 208. So maybe those are bowling scores, for example. And we're writing a high score list, and we do it this way. We could do that. We're capable at this point already of being able to do that. But there are a couple of other things that we're going to read and write to. And text files are great. But think about this. You've designed some new video game. Do you want your high scores just stored in a text file so somebody can edit it and suddenly they can have 1,000,000 points in your game? Probably not. So we're going to look at something a little more complicated. So there's a lot of different ways that Python can store data. This one is actually called pickling. So pickling data, so if I pickle something, I'm preserving it. And pickling in Python means we're storing our data and we're putting it into what's called a binary file or a .dat file. And so on page 201, we have some similar structures, binary file methods. And so notice RB is read binary, WB is write binary, AB append binary. So some of this works very, very similarly. Very, very similar. So we're going to look at how can we pickle data. So I'm going to go up here and I'm going to delete this real quick. And I'm going to call this one pickling data. And so we're going to be able to grab this data and put it together. So the first thing I'm going to do is I'm going to make a couple of lists. And I'm going to close out a whole ton of windows here because I got stuff open everywhere here. All right, so I'm going to write a couple of lists. And we're going to be able to create some pickles with them. So print, and I'm going to call this pickling my list. So I know about pickles a couple of things. I have a variety of pickles, and I'm going to call that. So we have sweet pickles, we have hot pickles, and maybe we have dill pickles. I know I have shapes, and so I have whole, I have spears, and I have chips, we'll call them, or slices, whatever you want to do that. I also know that there are brands of pickles. So we're just going to use the ones out of the book because I'm not a big pickle fan. And we have our friend Vlasic. So we have 3 different items here in lists. So we have a variety, we have shape, and we have brand. Well, just like when I did the text file, but this time I'm going to shorten it just even more. So we're just going to pick a single letter. And we're going to open a file, and we're going to call this pickles2.dat. Now, I'm calling it pickles2 because I've already got a pickles1, and I don't want to overwrite it at this point. So pickles2, and we're going to do this as a WB. So we're going to write binary. So we're going to create a file, and we're going to then do this. We're going to say pickle.dump variety. So we're going to pass that in, if I spelled it right. Y. I'm going to do a pickle.dump shape. And I'm going to do a pickle.dump brand. And then I'm going to close this. So f.close. So the pickle dump function says I'm going to grab those, pickle it, and dump it into a file. So if I run this now, I have an invalid syntax somewhere, right? Oh, I have a period instead of a comma. Oh. All right. So try that again. It's going to go, all right, error pickle is not defined. So I probably have a name wrong somewhere in there again. Pickle is not defined. What have I done? Oh, duh. All right, hang on 1 second. So pickle isn't already in Python. So just like our random, I have to import pickle. And so when I tried to run that, it goes, oh, I don't know what this pickle is. So now it ran, and I want to go look and see if we created a DAT file. And oh my goodness, we did. We created a .dat file, or a data file. I'm going to open it, and I'm going to try to open it with, let's just try it with Notepad++. It's on the computer. Oh, that doesn't look very easy to use. So I'm going to try it with Notepad, see if that looks any better. Now, I can get some of the data out of there, but it's really storing it in a binary file. And in most cases, we're not able to see even this much information. So I can't just read and write it easily. I have to use a function then to actually get it back. So we created it, we ran it, we have to move. Which one is that? Close that one. All right. So to get it back, we're going to unpickle it. Okay. So print, unpickle my list. So we're going to do something very similar, but now we're going to take it and we're going to unpickle my list. So F equals open. I'm just going to use F again, or you can use any letter. It really doesn't matter because you're not putting anything in there right now. Pickles 2.dat. And again, I know that it's in that same location. And now I'm going to read binary. So we're going to open it up, and we're hopefully going to be able to read that. So we're going to say variety equals pickle dot load. And then we're going to say shape equals and what is our other one? Brand equal pickle dot load. So we're next going to print those. So just to see if it'll work. So we're going to print variety. And I'm only going to do one just to make sure it actually does work. I'm missing one thing in here. I need to close that. So I'm going to say F equals, or F dot close will work. So we close our file. And we're going to see if it'll print variety out for me. And oh, it did. Sweet, hot, and dill. Now, if I mix up this order where I'm unpickling this, so I'm going to do this. Let's just move this. And I'm going to put it down below. We don't really have any way right now. So that's not variety, is it? So it's doing them in order. We don't have any way right now to say, hey, this item is associated with this particular thing. So we have to keep track of that order. So variety now is wrong because we pulled it out in the wrong order. Well, we can actually do one more step. And this is what gives us kind of this ability to grab these lists in random. So in other words, I don't have to download the entire file. I can do that. So when I do something called a shelf, so all of this, we're going to then add a shelf function to it. So just to keep track, S equals shelf dot open. And we're going to grab our pickles file, pickles2.dat. So shelving gives us the ability to organize things a little bit. And so S, so here's where we're going to put in that variety, equals, and then I'm going to grab this up here just because I don't want to retype those. So now I have the ability to do this. And so almost like those dictionary where we can search by variety and come in here. So I'm going to steal those really quickly. So now we can have variety, shape, and brand. In this case, I also have another command called sync that we can call at any time. And that sync just ensures that we're synchronized. In other words, it's writing that data. because we really do want it to write. All right, so our next step then is, can we pull it back from that? But let's see what happens when we run this first. So I'm going to guess we're going to have an error. And we do, because I have an indent issue there. What did I do? Oh, I didn't put my... All right, try that again. Oh, so shelf is not defined. So anytime it says it's not defined and it's a function, I think, oh, what else have I forgotten to put in there? Is it a function I created? No, it's one we can actually import out of the library. So we actually have to import shelf. So we could also, if we were going to use it, import our random at the same time. So now when I run it, we get a different error, and probably something I have done here. Really word shelf.open. So I have probably done some kind of weird typo of some sort. S equals shelf.open. Is that the right file name? S variety. So somewhere in here, I'm assuming I have some kind of an odd typo. What we do. Line 243, which we don't even have, so that's in that library. Trying to find out what I've done here. Line 26. So let me do. Now that might be something new and interesting. I might have found with the latest version of Python something that's different in a shelf function. Going back to interesting. I have broken the shelf function. All right. Hang on a second, guys, because that is interesting. Because that actually, I know this code actually worked, the code I just ran here a second ago, works on version 3.1. Are you guys able to get it to run on yours, or do you have the latest version also? I am going to have to look and see why they changed that. So let me abbreviate our... So the shelf is actually a great tool. I'm assuming we've changed some little bit of nomenclature, so I'll have to look into that really quickly. The shelf will also allow us to open it. And so the theory is, or the ability in that, is then I can actually open up by doing something like this. I can open up by that call name, which there seems to be, again, something that's changed. It won't affect what we're going to do here in a second, but I'll have to look into that because my older version works. I updated in the lab to the latest version, and so when we said there before, why, what kind of issues could we have updating to the latest versus the not latest? Well, there's a great example of it. So I am sure that the shelf function exists. It must have changed or had a slight change. So we'll look into that and see if we can figure out what we have going on there. So the other piece I want to look at then, let me back out of here really quickly, and it actually leads into a really good area to look at is, how do I handle when something goes wrong? And so this chapter has something called an exceptions handling and introduces you to that. And so let me close Pickle out of the way here. Close that. Close my text file. So Python has some error handling routines in it, and we can utilize those. So when things go wrong, so for example, when I did this file and it didn't work, the graceful way Python could handle that on your program running, if you did it correctly, is to come out and say, oops, that doesn't seem to work, something went wrong, let's proceed, and have an alternative. And so we'd like it if we had that ability to do that, and we do. So there is the ability to do something called a try. And so try will do something, and if you get an error, so let's do this. Let's automatically convert number equals float and input, please type a number. Well, we know that people are idiots, and half the time they're going to type in something wrong. 1, 2, maybe 1 more. So you say, please type in a number, and they're going to type in, write out 47, F-U-R-T-Y. So try gives us except. So if the try doesn't work, if some failure goes in, I said a number, you dunce cap wearing human. So now, if I run this, so it says, please type a number. And if I type in 4, it doesn't error out. Works like we thought it should. I run it again, and I type in 4, and it says I said a number. And so those errors we can get around by doing this idea. So try will give us that ability to do that. Now, it doesn't tell us what kind of error, but it's really a handy thing we can do so we can get around those. So if I had a try over here on my pickle function, it would have said, hey, the pickle function doesn't work, and we have to figure out what's going on with that. So we can do a couple of other interesting things, because occasionally it would be really handy, really handy, if we could find out what kind of an error it is. So now I'm going to do something very similar. I'm just going to copy this whole thing, put it down here, and I'm going to put in one more key phrase. And I'm going to put in here value error. And notice it turns purple. And so now it will give me a little bit of information. So I'm going to hit F5 again and run it. And so on the first one, I'm going to let it work. I'm going to say 4. But the next one, I'm going to type in the number 4, and it's going to give me an error. We hope. So in this case, if I look on page 207, I have a list of exception types. So if I do something different, so I can specify that this is only for a certain type of error. So here's what I can do. Let me show you why this is kind of interesting. So I can do an except for a value error, which in this case says when an inappropriate function receives an argument, but I can also get one, so for example, a zero division error. And I can do multiples of these. No, I can't spell division though. So I can actually do this with multiples. And so I could do the zero division error, and I can get it to output then a different message and a different module. So try anything that goes wrong. We can put in those excepts. We can put in the type of error you're going to have wrong. So if we're using a dictionary, there is a key error. There is a syntax error that you can actually use. So we can get some values. So you can actually combine them. So I'm just going to go delete that for now. And I'm going to paste. So you can combine several even. So you could say value error and type error. So you can have multiples. So maybe you have a third type and you're not worried about it. This would also work. And if I type 4, it's going to say, hey, here's my error. So these are really a handy way that we can control what people are going to do. So if I do something like, we want to have a conversion error, or we see that something is wrong. So let's do a for value in none. So we know that there's nothing there. And a text string. And then we're going to try to do something with it. And so the first thing we're going to do is try to print converting. And we're going to try to put value and watch what we're going to do. So we're going to do float, which is another type of we haven't worked with yet. So except, so type error, a string or a number. And then we're going to come back here and we're going to do another except. So we're going to do a couple of different things here. So depending on if it's a type error or a value error, we're going to get an entirely different message. So we could use that as a troubleshooting method to see what users are putting in, what's going wrong in our program. And when I run this, make that big so we can see it. It tries, I can convert a string or number, converting high. I can only convert a string of digits. All right, so we see that it actually gets both types of errors in this particular case. So this, we get because it's trying to convert a non-existent value. This one we get because it's trying to convert a phrase high, so hi, into a float. Does that make sense? Because we're actually we're converting both pieces. So this value has two values, and it's going to try to convert both of them, and it can't. So in this error, the type error says, well, the type is wrong, and this says I can only convert a string. So it's trying to convert a string to a float, which is a decimal if you want to look at it that way. In this case, it says that's not even a valid type. So we have a whole list of these that we can use to make our lives a little easier. So the other and last kind of interesting piece we can do is we can actually get it to tell you what that error is. So I'm going to do another try, and I'm going to do a num, and I'm going to try to float whatever input you put in. Input a number. All right, so now I need an accept value. And I'm going to do something here where I'm going to say value error is E, because that's our most common thing we're going to run into. And we're going to say print so we're going to actually get it to print out what the error message is. So we're now passing that from that error message that you'd see in red into a variable that we can control. So F5. Oh, hang on. Helpful if I put the colon in. All right, try it again. And I made it mad somewhere now. Hang on. What did I do wrong here? Value error is E. Oh, no, I don't want that one in there. Value error is E. What did I forget to put in here? 1, 2, 3, 1, 2. Ah. Try that. Match up my parentheses, and it would be really helpful. Float input, please input a number. Something I did wrong in my little bit of spelling. Let's take that out. Chunk. I got parenthesis happy here. Ah! Oh, duh. Hang on. It's been a long weekend. All right, so enter a weekend. Enter a number. So if I enter a number and I enter 50, that works. If I enter 4, that was not a number. Python says it could not convert string to float, and then it gives me a value. So I can use that as a very handy little method to figure out what's going on. So I could even create this. I could write that then to a log file. I don't necessarily need to print it, but I could say, hey, this is my error. This is why I'm getting an error. So for Thursday, make sure you have read chapter 7. We are going to create one more little thing. We're going to look at how do we create a trivia game using some of these items. So in this particular chapter, we're going to create a trivia challenge game. So nothing we haven't done before. You're going to create a game But this time you're going to do something a little different. We're going to put the game in a text file, and the program is going to read that text file. So we're going to work on that, and we should be able to work on some of the homework for this week and hopefully at least get the first half or part of that done. So same technique. We don't use the shelve and pickle function, so I will look and try to figure out what has changed. So clearly Python has made an update that I didn't know about or didn't find in here. Always fun and exciting. Sadly, I have some code that uses that, so I can't update on my computer or I'm going to break something. So I'll have to figure out what is different now with the pickle and shelf function. All right. For next week, remember we do have a final. It will be open and available fairly quickly. The coding section I will hopefully have open today, if you choose that. The other final I will probably then have open, so you have from Monday till Thursday night to do that at any point you choose. You will not be able to do it over 4 days, but you can pick your time when you want to do that. All right, any questions? All right, anybody want to earn extra credit by figuring out what happened to my shelf function? What? I said I'm offering extra credit if you email me what's wrong with my shelf function. Something? Well, I know there's something wrong with it. Or something has changed anyway. All right. Let's get out of here and have a great day. Enjoy the nice, cool weather.